For the first time ever, scientists have created a 3D model of a melting snowflake. 3D modeling, coupled with new research about melting snowflake behavior, serve as one of the first steps for creating better precipitation models, used for weather forecasting and climate modeling in the future. We've actually known how to measure the size and shape of snow particles for a while, but visualizing how a snowflake melts, that was only achieved in the last couple of years. Actually, by this guy, based at NASA's Jet Propulsion Laboratory in Pasadena, California, probably one of the least snowy places in the United States.
Nobody else was really doing it, and I kind of had a good hunch that it could be done.
In the past, researchers have adopted some pretty creative methods to catch snowflakes, like using spider webs to net the delicate crystalline structures in order to watch their melt behavior.
But I don't like the thought of writing this research proposal where I ask for money to breed spiders.
Understanding the microphysics of a melting snowflake has significant implications. About 66% of rain starts as snow higher in the atmosphere, and that layer of melting snow can, among other things, affect weather patterns, block radio signals, and be a hazard to aircraft. The hydrodynamics are actually particularly complex and completely different from the characteristics of rain or even snow that hasn't started melting yet, which is what prompted an entirely separate body of research. The team created mathematical models that simulate a melting snowflake in nature, allowing researchers to study its behavior in a controlled environment. It turns out that the degree of riming has a major influence on the melting process. Riming is the accumulation of super cold water vapor that freezes instantly when it comes in contact with a snowflake. Heavily rimed snowflakes look more like hard, dense ice pellets, while lightly rimed, fluffy snowflakes often maintain their light, delicate crystals. As you've probably already guessed, these fragile snowflakes melt pretty easily, whereas hail-like snowflakes are less prone to breaking up during the melting process.
Now we have the techniques and we have the computer power to actually make simulations of these things.